Okay, today we will discuss some interesting topic. We will look for some pattern in binary number system. It will make easier for us to understand some binary number like clearly or easily. So you look for some pattern in binary number system, some interesting pattern, and also you'll see how text is converted or stored in binary number system. We know that from the last class all of our information, it might be image, text, sound, all of these are converted to 0 and 1, and we already have the idea how number like 1 2 3 decimal numbers, these are converted to 0 and 1. We have some idea about this and we know how to convert decimal to binary. Today you will see how computer converts text to binary or some other characters to binary. So these are like important topic actually. If you understand this, you will have idea, basic idea that about computer principle. Okay, let's start. And if you have any question, you should unmute yourself and ask me the question during the lecture. Okay, patterns in binary number system. So always there are some patterns. You will have find some pattern in data. You have to seek it. Pattern in data, pattern in the information. So also in binary number system, we can see some pattern. It will make us easier to understand the concept. For example, and we now know how to convert decimal to binary. For example, here binary of 3 is 0011. I hope you can remember. We know how to convert decimal to binary, like we will use the power of 2, 2 to the power 0, 2 to the power 1, 2 square, 2 cube, and goes on. 2 to the power 0 means 1, 2, 4, so 8 4 2 and something like that. Okay, we know this. Then 3 means we have to make 1 here, 1 here, so we can give double 0 here, 0011. This is 3 in binary. And 5 means all of you have the idea how can you convert it. 401, that is 5. You can give a 0 here, 010. So 4 plus 1 is equal to 5. So we learned it in the last class. So I hope you can remember it now. Like we have some numbers. 3, its binary is 0011. 5, its binary is 0101. 7, its binary is 0111. 9, 1001. If you see the binary pattern carefully, you will see that, okay, first thing is that all of these decimal numbers, these are odd numbers. These are odd numbers. I hope you know what is odd and even. Okay, this is a decimal number, and if you see their binary conversion, you will find a pattern here. The pattern is on the ones place, in the last bit or ones placed, this one, this is the last bit, this is the first bit, second, third, fourth, or last bit. The last bit for all of this binary number, you will see that all are 1 here. You can see that the last bit or ones place is always 1. This is not 1 1, this is 1 actually. Is always 1. So I hope you already got the point. Whenever you convert a odd number into binary numbers, binary position or binary conversion system, always you will find 1 at the last bit. That means ones place. This is ones place, this is twos place, something like that. So always you will find 1 at the last bit. Did you get it? So for example, if I convert 11 to binary, what will be the binary conversion of 11? 11 will be 1
1011.
1 1. Good. That means here also at the last bit we can find 1. So this is a pattern. If I give you a question in the exam, something like that, okay, I will show it later. So I hope you got it. Very simple pattern. Always you'll find these types of pattern actually in mathematics or also in computer science, also some. So always you find this type of pattern. If you can seek the pattern clearly, it will improve your understanding. Now, if you see a binary number, you can instantly say that is it a odd or even. The last bit is one, that is odd. It's not one. That means if it's zero, you'll find that okay, it's an even number. Okay, so so we know that about at the last bit there is always one. Do you have any question? If you have any question, you can ask me. Okay, then there's I should make a correction here actually. It should be one. Okay, now we have some idea about this. Now, if
As
I
for even number,
yes,
in the last bit, always have 0 for even number.
yes, there will be zero always because
Okay, sir. Thank you.
okay, okay, you can check something some even numbers later also. You'll get it. Okay, now let's show it again. Now, see, if I ask you like some random numbers and we don't know what are the numbers here, it's some big numbers. If I ask you which of these are odd numbers,
Third one.
Third one.
third one.
Third one.
Yes,
Yes.
only the third one because the last bit is or one's place is one here. The others are odd numbers, sorry, even numbers. So whenever we find one in the last bit, we can instantly say that it's an odd number. Okay. So actually, you will find that I am just talking about the patterns and other things. Whenever we do some, like for example, whenever we do some programming or whenever we solve some problem by using binary number concept, you will find that this pattern will reduce our work. It will help us to understand something clearly. Okay, hope in future we will do something like that. Okay, these are the pattern. These are one type of pattern. Okay, this is another type of pattern. Like this. Uh, when a binary number has one in each of its places, this is the largest number that can be represented by that number of bits. What does it mean? That means it will be the largest number by that number of bits. For example, we have one here, like we have 1 1. So if we have 2-bit binary number and both are 1 1, if we have 3 bits binary number, both are 1 1, all of these are 1. If we have 4 bits, all of these are 1. That means when all of these are 1, this is the largest number that can be represented by that number of bits. For example, 3 bits. By 3 bits binary number system, largest number would be what? Largest number you can represent 1 1 1. This will be the largest number you can represent by 1 1 1 means 7. So by a 3-bit you can represent number 1 0 0 or only 0 0 0 0 0 1 1 1 0, something like that. All of these are 3 bits number. But what will be the largest number that can be represented by 3 bits? That is 1 1 1 will be the largest number. Okay, so 1 1 is the 1 1 1 is the largest number, that is 7. Similarly, in this by 4 bits, you can represent some numbers. Yes, like 1 0 0 1 1 1 0 1. But the largest number we know that by 4 bits will be 1 1 1 1. That means if all of these are 1, this is the largest number that you can represent by that number of bits. So if I ask you what is the largest number that can be represented by 4 bits, we'll say that 1 1 1 1, that is 15. Okay, so now you got another pattern. If I ask you a tricky question, something like that, for in the exam, for example, just if I ask you which one is the largest number, if I give you like 5 bits of number, if I ask you 1 1 1 0 1 1 1 1 1 1, if I ask you between these two which one is the largest number, The next
One,
one.
one, one, one.
One, 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 one. Very simple.
Sir, if we have one in all places, then it will be always largest.
Yes, it will be always the largest number by that number of bits. I hope you can remember in decimal, we did these mathematics in primary school level actually. In decimal, eh, if I ask you what is the largest number by uh, two numbers or two numbers of places, something like that. I forgot the term actually. So by two numbers, maximum number is 2, you can represent. What is the largest number? We know that 99.
Oh, 9.
Yeah, if I
Yeah.
ask you three numbers, it will be 999. All of our nines there. This will be by 3 bits or 3 numbers. The largest number is 999. Similar way, the same, almost the same concept. If I ask you what is the largest number in binary number system, where you have 3 bits, it will be 111. Where it will be 4 bits, 11111. Just remember this concept. I will give you some like in the exam, I might give you some question where you will need this concept. Okay. But these are easier concept. As I told you in the first class that from this class, there will be actually the very theoretical. It's part of data communication in computer science. So it's all a theoretical concept. Okay, now I hope you got it, the idea here. Today's class I will not take that much time. Now we have some idea about, and another thing, whenever pattern is very important feature in any field. You might work in history, you might work in philosophy, computer science, mathematics. You will find lots of patterns. So if you can find pattern from a lot of data, it will like make your work more beautiful, or it will ease your work. Like you can do some work in a less time whenever you don't have any idea about any pattern. And I hope you have some idea about some patterns in mathematics. You know about Fibonacci number or factorial, something like that. So you have,
So Fibonacci number, I forgot about this.
okay. We hope we will discuss. Whenever you learn programming, we will solve this. Then I might discuss some interesting thing about Fibonacci. You will find Fibonacci in nature also. Okay, we will discuss this pattern later. Okay. So I love to actually explore pattern and display or pattern something like that. Okay, now you have some idea. Now we will go for the another concept. This is very important concept. We know now we have really some good idea about numbers, and we have already idea how our computers or mobiles process our numbers in its own way, like means 0 and 1. Now you learn something about how actually computer process the text. So here I have given a link to the article. If you go there, you will get everything here. That is this article. Maybe this one, not binary numbers. Maybe I have to copy this actually. Maybe this is the video one. I think this one. Sorry, actually, no, this was our first one. Oh, sorry, storing text. So storing text in binary. So this is the article storing text. If you read through it, you'll get some idea about it. So these are all I am telling you again. I am talking about you the very basics of computer principle. So if you just read this article, it's enough. But I am encouraging you, please do try to explore more, something more about it. If you just Google these things, you will get lots of information. It will make you smarter. In the first class, I told you. Yeah, but I will ask you a question in the exam or anything from the class lecture, definitely. But if you read something more, it will increase your knowledge about computer architecture or computer principle. So I will definitely encourage you. Okay, fine. We know that if we write a message, hello or good morning to my friend, or if you give a status on Facebook, boom bam late, okay, fine. Like if you give a status on your Facebook, like good morning, and basically we know that computer process this good morning into 0 and 1, we know it. Or if you send a message to your friend like hello, your friend also receives hello, but in the middle of the communication, computer converts hello to some binary numbers 0 and 1. We know about this, but how it does? So I gave you some idea in the first class. I told you that there are some specific number for these characters a b c d etc. Also, whenever you give some emoji or in your Facebook, like you can see some emoji here on your Facebook, WhatsApp, whatever it is, some social site, we give the heart sign, smiley sign. This sign also have to be converted into 0 and 1. How it does these things? So we will just have the idea how it does. That's it actually for this section. How? For example, this is very simple. If you think it logically, if we give some a specific number for this sign, I don't know what is this sign, the first one. If you give like, if I tell that this is the 0 1, if I say that heart is the 1 0, and if I say that this smile is the 1 1, so this will be fixed for all of the computers. This is just an example. Whenever computer gets 0 1, it will understand that this is this sign. Whenever computer gets 1 0, it will understand that this is a heart sign. So it can easily then convert it, or it can easily understand or express it. So the main thing is that we have to set some standard for all of these characters and emojis in the whole world. Like heart always should have this emoji. It might be in WhatsApp, it might be in Facebook, like another like LinkedIn or Emo. There is another application Emo. So all of this application in the all of the computer system, always heart should be 1 0. This is just an example. Then all of the machine in the world will convert it in a standard way. So the main thing is that we will give some number. For example, if I give you some secret number, like we will, for example, I just we will go on a mission. Okay, like I have some, my soldiers are like here. I forgot all of your name. Okay, I know that here we have Faujia. Then we have who? Sakina. We have like Marikar or Faiza. Okay, Faiza. We will go on a secret mission. Then I will give some specific in the secret mission. Like I will tell that Faujia, I will give some secret code for the Faujia, some for Sakina, some for Faiza. Like I will give 0 1 to Faujia, 1 0 to Sakina, 1 1 to Faiza. So I am the captain. Okay, I am the captain. So whenever some of it, they will contact with me via mobile. For example, they will, whenever they will call me, Faujia will tell me that, hello, I am 0 1, and this is my message. So she will tell that, hello, I am 0 1. That means Faujia is not telling that I am Faujia. So I will get that, okay, 0 1, fine, that is Faujia. Then I will understand that, okay, 0 1 is the Faujia. This is like this the for my whole mission, the code will be the same. 0 1 is Faujia, and if someone calls me and tell that, hello, I am 1 1, and this is my message, I will understand, okay, this is Faija. So who can understand it? Captain can understand it because he has a code. He understands that who is Faujia, who is Sakina, who is. So what will make it easier? Can you just get? I actually I hope I can give you some idea about this. What will make it easier that in my, like in my memory, or in, I have a notebook. In my notebook, I don't have to write the whole name Faujia. If I write Faujia, Faujia, like I have to write more codes. For Sakina, I have different words. For Faiza, I have to like write more words, and there would be different words. But if I just process 0 and 1, always, it will be easier for me. My notebook, for example, can understand 0 and 1, and it's easier for it. Actually, there is no clear concept or explanation about these things. I'm just trying to give you some idea. So my notebook will have some standard things. Always it will convert it to 0 and 1 and something like that. Almost like this in our computer, whenever you write some word A, B, C, D, something like that, or some emoji, okay, or some emoji, always in our computer in the whole world converts all of these things into some specific numbers. Then computer converts it to specific numbers. It can easily then understand that what is the number, and if it gets, for example, 65, it will understand that okay, this is the capital A. If it gets 66, it will understand that okay, this is the capital B. That's how computer can convert all of these things. And okay, if I clear this and if I go down, so I hope, so what will happen, you can just read this out by yourself. What the thing is that computer has some standard for all of these characters. Whenever you press A in your on your computer, it converts to some numbers. Like capital A becomes 65, capital B becomes 66, a small a or lowercase a becomes 97, lowercase b becomes 98. These are the some fixed numbers, and these are called ASCII coding. ASCII means American Standard Code for Information Interchange. Yeah, information
Is it
interchange.
the 32-bit code?
Sorry?
Is it the 16-bit code?
No. I'm come to this one. Very good question. This is not actually 16-bit. So this is the ASCII coding. So ASCII means American Standard Code for Information Interchange. So this is fixed for the whole world. That means the engineer sets some point, the whole sets some standard, and this is the table actually. It looks tough, difficult. I will give you another image or picture of the ASCII table, but if you read through, you'll understand it. You don't need to worry about this table. I will give another table, but the summary
I
that
understood it.
is
It is the same for the
yes,
intermediate level.
yes. The thing is that always you have some like your delete key has some ASCII numbers. So if I show this one, I think I have another image here. I don't know. I have this one not. I just collected it from maybe some site. Okay, if you like always 0 is null, start of text 32, like see a space, whenever you press on your computer a space button, computer understand actually 32. Computer converts a space to 32 and exclamatory sign to 33 and this quotation mark to 34, this hash sign to 35. That means okay, then capital A, I hope you can see capital A, it converts capital A to 65, capital B to 66 and goes on. It converts a small a to 97, a small b to 98 and goes on. That means whatever you can see on your keyboard, hash, escape sign, backspace, F1, F2, Windows button, your shutdown button, delete button, all of the things on your computer, these are converted to some numbers, and these are fixed for all of the worlds. The whole machine in the world has this standard. That means whenever you press this percentage sign on your computer, computer understands this percentage. How? Because first of all it converts it to 37. It gets actually 37 there. Whenever you press percentage, computer gets 37. Then it converts this 37 to 0 and 1. So whenever we press any text, always all of the text, all of the keys on our keyboard has some number, a specific identification. And like it has some decimal number actually, 5, 6, 67, 68, and it's this thing. Then computer converts, and computer, we know that how computer converts decimal to binary. Then computer converts this to binary number. Then it can process the information. It can do calculation, It can do adding, subtracting the things, or it can send the message. Doing the processing is done always by using 0 and 1. So before coming to that, can you see my screen, all of you?
Yes, sir.
Yes,
Yeah,
sir.
sir.
Okay, okay. So then before coming to the main message again on the screen, it again it's converts to the main point or something like the 37. Because whenever you press like A B C D on your keyboard, on the screen you can see A B C D, but it does it computer instantly converts A B C D to some numbers, some binary numbers. We know that capital A is 65, capital B is 66, 67, 68. Then computer converts all of these to some binary numbers and it processes the information. Then again it shows us A B C D, because binary to whenever it needs for some doing some operation, some information, we will learn about these basic things later. It converts this to 0 and 1, and we know that computer operates or processes the information by using 0 and 1. But before displaying it on the screen, again it converts 0 1 to ABCD, the same reverse way. If it knows how to convert ABCD to this number to 0 1, it can easily convert 0 1 to these numbers of these keywords. But the main thing is that, try to understand it, the main thing is that computer, all of the things has some specific identification, and then computer gets this, it can easily convert it. So this table, whatever you can see, this is a table. This table is called ASCII table, and ASCII work with 7 bits. 7 bits, that means it can store, ASCII work with 7 bits, that means it can store 2 to the power 7 or 128 characters or numbers. Okay, so ASCII has, but you know that's another version of the ASCII now in a standard version, that is 8 bits, but it's not 8 bits means it will store more numbers, but the main ASCII is 7 bits. I will discuss something more. Just remember it. If our computer use ASCII standard code, it can only represent or convert only 128 symbol, character or number. But so that means it can only convert 0 1 2 3, some star, plus, minus sign, greater than, less than sign, add sign, ABCD, ABCD to Z, ABC to the Z. So it can convert actually English alphabet at some characters, plus, minus. But if I ask you, like for example, in Chinese characters, Chinese alphabet, or Bangla alphabet, Arabic alphabet, they have like more alphabets. In English, we have only 26 maybe, isn't it? I forgot. 26 alphabets. But isn't it 26? One. Yes, 26. So in English,
Yes, sir.
I forgot actually. So in English, we have only 26 alphabets. But in Bangla, maybe you have
49.
49. Yes, vowel and consonant, total 40. So for representing Bangla, and in Chinese, we have maybe more. I have no idea about it. It should be more. So if like we can write Bangla on our keyboard nowadays, we can write Chinese on our keyboard, on our computer. We can write Arabic on our computer. How? We know that ASCII cannot do it because ASCII is fixed. We can see it. ASCII only converts these 128 numbers. So what can we do? Just think it, what I'm telling you. What can we do? So ASCII can work only with 7 bits. Okay, 7 bits. That means it can store 2 to the power 7. It can only convert 128 numbers. If we increase our bit, if we can use like some another standard like ASCII, and if we can represent here 8 bits or 10 bits, 2 to the power 10, we know that it will be stored to store more characters. If we know about another encoding system which can store more bits, like 16 bits. So we know that if we have, if our system can store 16 bits, we can store more characters or more numbers. If our coding system can store 32 bits, then it can store huge number. Did you get the idea why we need another encoding system? So here it comes some other encoding system, because ASCII is not perfectly like encode.
That
It
32-bit
Yeah,
one,
it has.
isn't it called Unicode?
Yes, the 32 bits, there is a very common coding system, and most of the computers in the world use it, and this is Unicode. I will show it. So I hope you got the idea. If I ask you the question, we have already the ASCII standard, why should we need Unicode? So there is no fixed solution, fixed answer for this. You can express it in your own language, but I hope you got it. You got the point. So I will ask these types of questions, but I hope you got it. So in the Unicode, actually 0 to 128 is the same as ASCII, but most of the things are then different. So I hope now, do you have any question about this, all of you?
No, sir. Yes, sir.
Okay.
So we have to memorize the start.
No. You don't have to memorize this stuff. No, never. I will just ask you a few questions about this.
What
Okay, sir.
kind of
Thank you.
questions? Give us
Okay.
example.
Okay, all of you. That's the calm of, so that's the rest. So when it comes to the Unicode. So in this article, there you have more. You can read more, but just try to read ASCII and Unicode. You don't need to go for all of the things, but for your understanding, you can go. Like you have UTF-8 and some other also. But the main thing is that in you already got it. Why we need Unicode, and actually what is the benefit? The benefit is huge. For example, in ASCII, I'm just showing you an example. We can use 2 to the power 7, 7 bits, ASCII 7 bit. So we can only store 128 characters and numbers. But see, in Unicode, we can store up to 32 bits. If I make it 2 to the power 32, see what is the difference. This is huge. This is billion. So here we can, in ASCII, we can store only 128 numbers, but in Unicode, we can store maybe 4 billion. This is. Yeah, 4 billion. But so in Unicode, you can store 4 billion alphabets, numbers, characters, all of the things. So it's huge. So I hope you got it. So I might ask you what. So just read the concept. So in this type of, in the upcoming exams, basically I will assess you according to your knowledge. Almost, although the things will be very basic. Like I will ask this types of critical question.
Sir, what is this?
This is a calculator. This is a, like I got it from Google, exponent calculators, to find the power of
So, sir,
something.
uh, for this question, we have no space to
Sorry.
answer the question in our own words, right?
Yes, in your own word. Something like that. So, but what I will give or ask you the question definitely from my lecture, and you will get everything. Okay, now I hope you got some idea.